Thanks very much, Alice. Actually, I think I want to change fields and start taking the classes that Charisma is teaching. Those were fascinating. We all have a front row seat on the problems that healthcare delivery has today. We're struggling to, many people get access to testing, figure out when we're going to get vaccinated, all driven by a little virus. And this has just made clear the holes in coverage, the lack of the ability to address the many needs, even in regions that are economically well off. And so you can imagine in many parts of the world, access to healthcare is strained beyond any capacity by the conditions today. And it has allowed us, I think, an opportunity to really rethink healthcare, to engage in a holistic transformation of how we collect healthcare information, how we think about delivery of therapies, and how we want the economic system that underlies that to change. So for all the horrible things that are happening in the world today, I think it's interesting to think about this being also an opportunity for changing the way that healthcare is delivered. And that's really what this part of the DevEng program is aimed at, healthcare transformations. Now, there are a range of courses that are available in this area from departments across the campus, especially in public health, but also in bioengineering, that provide foundational knowledge on the issues that are faced by individuals in the healthcare system, the economics of the healthcare system, some of the physiology of disease, and in particular of infectious diseases, as well as some of the technologies that we're trying to bring to bear to change the way that healthcare is delivered. So maybe on the next slide, I'll summarize some of the work that my lab is interested in doing. Essentially, we're hoping to increase access to healthcare by using technology. And here's an example of how we're working on converting mobile phones into microscopes that can aid in the identification of pathogens, diagnosis of diseases, and can do so without the infrastructure of a normal clinic or hospital that's required. And the way that we want to approach these problems is by taking advantage of what these mobile phones can do, not just their ability to take images, but their ability to process information at the point of care and guide in the decision-making about treatments. Projects related to this that we've pursued have ranged from looking at blood samples for malaria parasites, looking at sputum samples for tuberculosis, looking at urine and stool samples for soil-transmitted helminths and schistosomiasis, as well as parasitic worms in blood that are related to treatment of river blindness in Central and West Africa. For that project, we've been able to deploy a set of mobile phone-based devices that can detect the presence of parasitic worms in blood samples and quantify how many worms are there automatically. And that provides information that aids healthcare workers in deciding whether to treat someone with a drug or not. And those sorts of technologies really leverage the mass production of mobile phones that has driven costs down and made it possible to bring technologies in places that they haven't so far. The actual device that's shown on this slide is one that we've put together very recently to help with the current coronavirus challenge. And this combines the ability to measure fluorescence with a mobile phone with a CRISPR Cas enzyme, Cas13 enzyme that Jennifer Doudna's lab discovered, and for which she's being awarded the Nobel Prize actually today. That enzyme is able to recognize RNA from a virus, given a certain guide RNA. And once that parasitic, or rather the virus RNA has been detected, it will become an enzyme that cleaves other RNA, and we can put a reporter in and then detect that fluorescence with the mobile phone. And so in this way, we're hoping to take what is normally a lengthy laboratory process and put it into a compact package that can enable point of care detection of diseases like SARS-CoV-2, but also other viral and non-viral diseases. This type of effort really requires a community of people who think not just about how does a mobile phone sensor work or how does an enzyme work, but how do we deploy it? How do we engage communities to participate in healthcare? What are the right ways to finance something like this in a sustainable way? What are the materials that we should be using to ensure that the devices and the disposables are appropriate for the region? All of these require the kind of community that the Blum Center and the Development Engineering Program brings together. So it's a pleasure to be a part of this.
Thank you, Dan. Could you say a bit about the lab you're creating here?
Yes, we're working on putting together a makerspace, which we're calling a Health Technologies Collaborative Laboratory. And the idea is that students with projects that would benefit from resources, fabrication resources that would aid in the development of prototypes or testing or sample collection. We want a place on campus that will be a home for development of healthcare technologies. And so in Blum Hall, we've identified a space and are renovating that space to enable student groups and faculty as well to come together to try and solve big problems in healthcare delivery.